Okay, so this is what's going on the back of your triangle page. We already talked through it. Please add it. Okay, so our first step is to create this chart. These are already given in your guys' review. The next step is to write your givens into the chart. So you had this given in your problem. You write it in. You say that it's given. Step 1. Step 2 is we're going to put that onto our picture. So we see that AB is congruent to CB. And we see that AD is congruent to CD. So right now I took what I knew and I just drew it onto my picture so I could see it. Looking at this, I see that I have two sides. So I have two options to prove these triangles are congruent. So looking at what we're trying to prove that our two triangles are congruent. I have two sides. So which ones have two sides? On the sheet, which one has two sides? SAS and? SSS, right? So side, 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 or side, angle, side. Right now, we're looking here. We have two sides. If we were going to use SAS, we'd have to show that these two angles are congruent. Do I have any information that shows me that these two angles are congruent?
No.
What do we know about this side?
It's
shared, so we have to use that property. So on that list we just made, that was that last one I put in. So if you see a shared side, you're going to write 2. BD is congruent to BD. And we know this by reflexive prop. You are 100% correct. Okay, that tells me right here that I now have 3 congruent sides. Now that I've found that I have 3 congruent sides, my last step is to say that my two triangles are congruent. So 3, we have triangle ABD, which is congruent to triangle CBD. And how did we know that? Not given. How did we know it? We proved it by congruent side, congruent side, congruent side. So we know it by side, side, side. So this, if we're proving congruent triangles, will always be one of those 5 methods of proving congruence. So this is our first proof on this page. You guys have any questions on it? Okay, I'm going to clear the slide and scroll down. So for our second one, we see that AB is congruent to CB. So AB is congruent to CB. And we also see that AD is congruent to DC. Now we are trying to prove that an angle BAD is congruent to angle BCD. So now we're trying to prove congruent parts. So that's one step past what we just did. So first we have to show that our triangles are congruent, and then we can show that the parts are congruent. So how do I show that this triangle is congruent? We're going to use that property again, right? So we see that BD is congruent to BD. And we know that by the reflexive prop. So when you see that shared side, if there's nothing else obvious, that's the one in doubt. We're going to go with that side. Use the property, show that it's congruent. So our next one is now to show that these triangles are congruent. So we know that triangle ADB is congruent to triangle CDB by which congruence of triangles method? Which postulate theorem are we using? SSS, side, side, side. Because we have 3 congruent sides. So our last part here is showing that the two angles are congruent. So now that we've shown congruence, we can say that our angles are congruent. So we have angle BAD, which is congruent to angle BCD. And how do we know these are congruent? So on the proof writing steps, this is the last thing that I had you write down. So on the steps, say it one more time. We know it by CPCTC. Corresponding parts of congruent triangles are congruent.
I understand.
So once you've shown that the triangles are congruent, we can pick the parts that are corresponding to say that they are congruent. So right now we have that AB is congruent to CB. Okay, so we see that AB is congruent to CB. It's the first given. Our second given is angle ABD is congruent to angle CBD. So these look a lot like that first page proofs, right? But now we are given congruent angles. So now that we have that, we need to show that these triangles are congruent because that's my ultimate goal. I have a side and I have an angle. Which one of these methods, I'm going to borrow this, can we possibly use? One that has a side and an angle. Dion? We can use side, angle, side, and that's convenient. He already saw it. Side, angle, side. So we have to show that this side is congruent. How do I show that that side is congruent?
It's reflective.
So we can now say BD is congruent to BD. And we know this by
Reflective.
Okay, now that we have that, we can now say that my triangles are congruent. So we say that triangle ADB is congruent to triangle CDB. And how do we know that?
Because the
Which one of those congruents?
Is it AAS? SAS?
So it's going to be side, angle, side because we have two congruent sides and an angle that's directly between them, in the middle of them. So we know it's side, angle, side. So that is this whole proof for this one. All we're showing is that these two triangles are congruent, and we have successfully done that. Okay, so now we are looking at the same given statement. Segment AB is congruent to segment BC. And angle ABD is congruent to angle CBD. So again, our goal is to show that we have D is the midpoint of our segment. So to show something is a midpoint, yes, Randall? Oh, for congruence? Yep, so we're going to use exactly what he wants us to show. So we want to show that these triangles are congruent. And so to show that they're congruent, he wants to use SAS. So again, we have to show that this side is congruent. How do I show that that side is congruent? So we have BD is congruent to BD by reflexive prop. This is on the back side of the one that Dion gave us. So if you're looking for those properties actually written out, the transitive and those, that's on that page. So now we have this portion. We can now say that the triangles are congruent. So 3, triangle ADB is congruent to triangle CDB. And how did you know that, Randall?
Because SAS.
Yep, from side, angle, side, SAS. So now we've proven our triangles are congruent. Our ultimate goal is to show that D is the midpoint of AC. So on our list on the back of that triangle page, I had you write out what you need to show midpoint. What you need to show the midpoint. Yep, you need to show two congruent segments. So for this to be the midpoint, I have to show that AD is congruent to DC. So how can I say that AD is congruent to DC? So we would have been if we were just looking for the triangle congruence, but now we're trying to prove that D is the midpoint. How am I able to show that those two segments are congruent? So if you've already proven congruence and you're trying to show congruent parts, it's on that same page. What rule can we use?
HL.
Not exactly HL.
SAS, no.
So we're no longer using any of these first group. None of these first bolded 5 are eligible because that shows congruence of triangles. I heard it somewhere.
CPCT.
Yep. So we can use CPCTC. Corresponding parts of congruent triangles are congruent. So we are able to say that because of CPCTC. Okay, our last step. Now that we've shown that those are congruent, we can say that this is the midpoint. So remember, your last step of any proof is always going to be what you set out to prove. So D is the midpoint of AC. And we know this by definition of midpoint. Sorry, I didn't hit record when we walked through this whole proof, but it's up here. We'll walk through in the next one. Okay, so our next one, we see that E is the midpoint of segment BC. And we see that AE is congruent to DE. So we're going to draw in what we know. So we see that AE is congruent to, DE. And then our second part is, based on the fact that it's a midpoint, what do we know? So BE is congruent. Be careful. BE is congruent to EC. And how did we know that? It's the definition of a midpoint. Okay, we've seen this, right? How am I going to show that these triangles are congruent? So we have two sides. We can either show a third side or an angle that's in between the two sides. Which one do we have a better chance of showing? The two sides or the angles that are between? The angles that are between, right? That's the only one we have the information for. So we can say that angle AEB is congruent to angle DEC. And how did we know that? Vertical angles. Okay. Now we can say our two triangles are congruent, but that's not all we're looking for here. We want to see that these triangles are parallel. Give me 1 second. And we knew that from side, angle, side. So we have to show that those angles are congruent. So we see that angle A is congruent to angle D. And we know this because of corresponding parts of congruent triangles are congruent. And then last but not least, we can say that AD or AB is parallel to CD. Yep, this is our last part. And we know that these are parallel by what we had to look at on the screen picture. And we know that's because of the alternate interior angle theorem. So we know that triangle ABC is an isosceles triangle with base AC. And we also know that segment BD bisects angle ABC. So 2. So this is not exactly the same because we have different given information. So based on the fact that it's isosceles, what do we know? What does it mean to be an isosceles triangle? It has two congruent sides, and that base is not the congruent side, right? Well, it could be, but in this case, we know it's not. So we know that AB is congruent to BC based on definition of isosceles triangle. Okay, our next part is we have to use the second part. That BD bisects angle ABC. What does it mean to bisect and what do we have to show? So on that thing I wrote down, it tells you if something is being bisecting an angle, what do we have to show? We have to show the two angles are congruent. So we know that angle ABD is congruent to angle CBD.
That's a man.
And we know that based on, what do we know that based on? Definition of angle bisector. We have 4. We need to show that these triangles are congruent. How do I show these two triangles are congruent? We have a side. We have an angle. We can either show that another side is congruent or another angle is congruent. Which one do you think we have a better chance?
Side.
Some people are saying side, some are saying angle. When you see a picture that has a shared side, what do we know we can use?
Flexibility.
So you have a shared side. That last thing on that page we wrote out, it said, if you have a shared side, which one do we use? We get to use that reflexive property. So I can use BD, gentlemen in the front, please stop, are congruent to BD based on reflexive. So that means this. Now I can say my triangles are congruent. How do I know they're congruent? I've got a congruent side. I've got a congruent angle. I've got a congruent side. The angle is wedged between the two sides. Side, angle, side. Okay, so for our next one, it starts out the same way. We have triangle ABC is an isosceles triangle with base AC, and we have that BD bisects angle ABC. So our second step is to show that side ABD, or nope, side AB is congruent to side CB. And we know this by the definition of isosceles triangle. Step 3 is that angle ABD is congruent to angle CBD. And we know this by definition of angle bisector. So right now we know that this is congruent to this, and this angle here is congruent to this. So we want to show that these two triangles are congruent. And to do that, we need to either show that another angle is congruent or another side is congruent. And right now what we have is the extra side. So we can show that BD is congruent to BD by, oops, that's supposed to be a 4, a reflexive prop. For number 5, we now get to say those two triangles are congruent. So triangle ABD is congruent to triangle CBD. And we know this by side, angle, side. Because we had a side here, an angle here, a side here. And now we have that. We want to show that that is the midpoint. So to show that it is the midpoint, we need to show that AD is congruent to DC. So I can say that segment AD is congruent to segment DC by our favorite CPCTC. And then 7, we can say that D is the midpoint of AC. And we can say that by definition of midpoint. Definition of midpoint. Okay, so for our next one, we are showing, we want to prove that triangle ABE is congruent to triangle DCE, sorry about that. And we are given the fact that AB is parallel to DC and that E is the midpoint of BC. Again, it's written out for you. Tomorrow it won't be, so you're going to have to remember to do that. So stay at part 2. We want to show what we know. So we know the fact that E is the midpoint, so that lets me know that BE is congruent to EC. So BE is congruent to EC. And we know this by the definition of midpoint. We also know something else interesting. This is the first one that has given us a parallel line to begin with. So remember when we do parallel, we write the little arrows to show which lines are parallel to each other. So I have these two lines that are parallel. Because they are parallel lines, they're being cut by a transversal, AD, or by BC, we know something about the angles on the inside. So I know that this angle here and this angle here are congruent. So I know angle A is congruent to angle D. And I know this because of alternate interior angle theorem. Okay, so now I have a side and I have an angle. So I either need another angle or another side. So that's not terribly helpful. So right now I'm going to choose to use that same theorem and show that B is congruent to C. So we know that angle B is congruent to angle C based on that same thing, alternate interior angle theorem. In all honesty, at this point, we could have also used vertical angles, and it would have actually put us in a very similar position. So now I have two angles and a side. My side is not between my angles, so I can say that triangle ABE is congruent to triangle DCE. And I can say this because we have two angles and one side, and the angle is not inside the side, by angle, angle, side. I also have number 6. I don't need number 6. Sorry about that. My only goal was to show the triangles were congruent. I did that in 5 steps. Okay, our next one, I'm going to replace the slide so I can scroll down. So our next one right here, once again, we see that AB, it's parallel to CD. And we also know that E is the midpoint of BC. So step 2, based on the fact that it's a midpoint, we know that BE is congruent to EC. And we know this is because of the definition of a midpoint. Step 3. Now that we know that's the definition of a midpoint, our ultimate goal here is to show that E is the midpoint of AD. So I can run through very similar steps to my last proof. We see that they're parallel lines, so that means that angle A is congruent to angle D by the alternate interior angle theorem. I also know that C is congruent to B. And I know this based on that same theorem, alt interior angle theorem. So once again, I can say that my triangles are congruent. So I have triangle ABE is congruent to triangle DCE. And I know this by angle, angle, side. Remember that side is not included. So to show that it is a midpoint, so on that sheet that I wrote out with you, you are able to show that something's a midpoint based on the two other segments are congruent. So we want to say that AE is congruent to ED. And I'm able to say this by our favorite CPCTC, corresponding parts of congruent triangles are congruent. So now that I know I have congruent triangles, the corresponding parts have to be congruent. And then 7, we know E is the midpoint of AD. And we know this by that definition of midpoint. Okay, you don't have to do any of the next page. This was the end of it. Study hard. Let me know if you have any questions.